Firstly, we are going to start with the introduction of semiconductors. So, what is a semiconductor, you might ask? A semiconductor is a material with electrical conductivity that falls between that of a conductor and an insulator. Semiconductors can be pure elements like silicon or germanium, or compounds like gallium arsenide or cadmium selenide. What is the importance of semiconductor? It controls and manages the flow of electric current in electronic equipment and devices. Examples of semiconductor devices that we use in our daily lives are solid-state drives and microprocessors.
So in this slide, I'd like to focus on our second topic, which is the automation application in semiconductors modern technology. So there's four different categories. The first one being IoT, or Internet of Things. Devices like smartwatches, fitness trackers, and smart glasses are packed with semiconductor technology. They collect data, process it, and connect to the internet to give users real-time information. The second one is artificial intelligence, also known as AI. AI relies heavily on semiconductors. The processors like GPU, also known as graphical processing unit, and specialized chips used in AI tasks like image recognition, language processing, and data analysis are all based on semiconductor technology. So the third one is healthcare and medical devices. Semiconductors are used in a wide range of medical devices, from diagnostic equipment like MRIs and X-rays, which they have in hospital and clinics, to wearable health trackers like smartwatches. They enable real-time monitoring of health metrics. For example, like smartwatches, they could read your pulse, and then the AI will analyze if you're having a bad day or not, basically. So the fourth one, smartphones and tablet. Semiconductor are the brains inside your phones. The chips in smartphones, powered by semiconductor technology, handle everything from running apps to processing touch input. So I'd like to talk about our third topic in this slide presentation, which is the evolution of automation in semiconductor manufacturing. As semiconductor manufacturing has advanced, automation has become crucial for producing the highly complex chips that power modern electronics. Here, the simplified timeline of automation in semiconductor manufacturing. So the first one is in the year 1990s, fully automated fabrication system and advanced process control system is created, and in the year 2000, precision automation for small, more complex chips is invented. And in the year 2020, the autonomous system, advanced robotics, and AI driven manufacturing for next gen chips like quantum and AI processors is invented.
Hello, I hope all the watchers have a nice day. Today, I would like to do a presentation about step in semiconductor manufacturing process. The first process is we have to do a circuit design before we have a wafer fabrication. The circuit design here, we can use a ORCAD or any software that can do the circuit design, such as integrate circuit creation. Next, we have a wafer fabrication. Wafer fabrication is the process for creating silicon device. Such process is such as silicon wafer dicing, deposition, and doping. After we do the wafer fabrication, we have a probing where we do a testing and validation process to assess the performance and function before packing it. Usually, we use automatic testing equipment to do the test. Then, after we do the probing and the test, we have the assembly test. This is where we transform function semiconductor that where you test into a wafer into the finished product. Then we have the final test of the product. After that, finally, we have a board assembly where we use integrate IC, resistor, and other electronic device, and we join it together into a PCB.
Well, automated test equipment, that is ATE, refers to any apparatus that performs tests on a device known as the device under test, that is DUT, using automation to quickly perform measurements and evaluate the test results. Normally, ATE system using in semiconductor industry to test the integrated circuits, printed circuit boards, and others like electronic components. Well, from this slide, we can show a semiconductor packaging technologies developed over the decades from the 1970s to the 2010s. In 1970, it's going in a dual line package and they upgrade to quad flat package and it's going to a smart outline package. Then in 1980, it's going to a leadless chip carrier. Then it's upgraded to a pin grid array. Then in 1990, it's going to be using like ball grid array. Then quad flat not leads chip package. Then chip scale package. Then in 2000, they're using system in package, then package on package, and using a wafer level package. Then lastly in 2010, They try to using a 2.5D integrated circuits, and they upgrade to 3D integrated circuits. Well, this timeline highlights our semiconductor packaging has evolved to support smaller, faster, and more efficient electronic devices.
I would like to present about the engineering roles in semiconductor industry. The first one we have semiconductor equipment engineer, which is to maintain and calibrate and optimize manufacturing equipment. The second one, which is facilities engineer, to manage your utilities and clean room infrastructure for semiconductor manufacturing. The third one is failure analysis engineer, which is to identify and analyze defects in semiconductor device to improve reliability. The fourth one is product engineer, which to develop and optimize semiconductor product to meet design and performance standards. The last one is packaging engineer, which is to design packaging and to protect semiconductor device and ensure the device is function to ensure that the device is functionally alright. So that is the last part. Alright. So we go to next part.
Now we have arrived at the discussion corner, where we ask ourselves and discuss the questions that have been popping into our heads after learning about this topic.
Implementing AI in automation material handling system. As we all know, artificial intelligence AI has become transformative force across all industries, reshaping how we work, produce, and innovate. Today, I want to focus one of the most impactful application of AI, its role in material handling system. It enhances efficiency and productivity by enabling intelligence monitoring, real-time data analysis, and adaptive decision-making. AI helps detect inefficiency, performance, ensuring minimal downtime and maximum output. One powerful application of AI is through convolutional neural network, or CNNS. This advanced algorithm process visualize data to identify objects, classify materials, and monitoring operation. They can detect defects, verify proper packaging, and streamline workflows, offering valuable insight that involves accuracy and reliability while reducing costs.
So in the discussion corner, I'd like to talk about the automation technology contribution in the semiconductor industry. I think there's many contributions being made, but I would like to focus more on the precision manufacturing. Precision manufacturing is where robots or robotics is involved, and robotics is automated systems and robots ensure high precision wafer fabrication, lithography, and assembly processes. Automated robotic system handles wafers during various stages like etching, deposition, and testing, ensuring consistent positioning and minimizing physical contact. I think where a robot is involved in this context, we use a wafer fabrication process as an example, which require precision and less little to no mistake that human has always been associated with and will cause problem to the chip production, for example. Which brings us to the next point, nanoscale accuracy. Automated tools achieve the microscopic precision required to produce semiconductors at sub 10 nanometer scales, which is beyond human capability. For me personally, I would even barely see an object about half a miles away from me, so I don't think I can see an object the size of 10 nanometer scales in my palm, logically. So I think that's why robots and automation system is involved in this case, and so that the chip production will go easily and without any hassle. And I think that's one of the main reasons I'd like to learn more in the automation industry and robotics, and also the semiconductor industry as well.
So, in conclusion, automation is essential in modern wafer fabrication, improving yield, quality, and efficiency while minimizing errors and contamination. It ensures consistency, enables predictive maintenance, and enhances equipment effectiveness. As semiconductor technology evolves, automation will remain critical in meeting demands for higher performance, lower costs, and faster production, driving innovation in the industry.
Okay, that's all for the presentation for my team and me. So goodbye and thank you for watching this. Bye.